Hey, how are you guys tonight or today, whenever you decide to watch the video? Today, we're going to talk about Chapter 2, The Chemistry of Life. And this is a really long slideshow, and I'm going to move through it fairly quickly. But you can always pause, and then if you have questions, you can always email me. I will love to help you out with this. If we were in a classroom together, I'd be writing on a whiteboard, but this is what you got with online. But you also have my lectures to look at with the PowerPoints to follow along. So let's get it started here, guys. So it always goes back to that first one. Sorry. Okay, I kind of put for chapter 1 and 2 together because it's not crazy long. I know some of you are like, there's 110 slides on this. It's not crazy long, but yeah. Sorry, it's biology. Okay, so chapter 2, Chemistry of Life. So when we talked the other day about biological organization, we said the smallest unit of matter is an atom. Okay, and an atom is anything that has mass and takes up space. Now, atoms are small, and they're made up of subatomic particles. So atoms are made up of protons, neutrons, and electrons. Protons have a positive charge. Neutrons have a neutral charge, and electrons have a negative charge. And atoms themselves are neutral. Okay, if an atom becomes charged, whether an electron has been added or lost, okay, if an electron is lost, that becomes a positive, okay, atom, but it becomes an ion. It changes its name. If an electron is gained, it becomes negative. And we'll kind of talk about that positive and negative attraction here in a minute. Elements are just your basic building blocks of matter. There's a lot of elements, on those big periodic tables that were in your science classrooms. I don't care about most of them. I care about 5, okay? And the most important one is carbon, and then hydrogen, nitrogen, oxygen, and phosphorus, even though it's not on this slideshow. I remember those by calling it CHON P. Easy to remember, that's why I put that in the blue, CHON. I don't get paid to make these PowerPoints because they're your book PowerPoints, but I kind of added a couple of things in blue for you before I decided to, record my lectures. So we need to worry about CHON. Those are important to us. Now, there's different, like atomic number and atomic mass. Those things are important when you're taking a chemistry class or like a majors biology class. But for this class, I don't really care that much about that. I want to talk about isotopes, though. I do care about those. Those are atoms of the same element, but they have a different numbers of neutrons. They're important to us in anatomy because we use those as radioisotopes. Those are unstable isotopes that emit some low-level radiation. And we use those as medical imaging so that we can see if there are tumors or if we can see brain activity, just different things. And it's just some little pictures for you. So molecules versus compounds, okay? Molecules are atoms bonded together, okay? And it can be made of the same or different, doesn't matter. So you like oxygen, O2 is a molecule, but so is water, H2O. Compounds, though, are molecules made of different atoms, like water, but not oxygen. And if we're making compounds and molecules, we have to join that together. We have to hold that together with something, and those are called bonds. And we have 2 that I really care about in biology, and technically 3, but we'll talk about that when we get to water. We have ionic bonds and covalent bonds. And when I talk to you about the atoms, like one of them can gain an electron and become negative, and the other can lose an electron and become positive, that opposites attract thing, that becomes a bond, and that is an ionic bond. And so it's where you have a positive atom and a negative atom join up, kind of like Thomas train, when you're like joining the magnets of the little train. And ionic bonds, that's, a lot of times those are your salts. And then covalent bonds, though, share electrons. And those are really strong bonds. And I think about trying to remember some of these big words, and I try to like have stupid ways to remember things. And so co means to me share. Like you share an office with your coworkers, or you share a building with your coworkers. In education, your co-teacher, you share a classroom with that teacher. So you share, and that's how I always tell my students to remember covalent bonds means that we share electrons. So now we're going to talk a little bit about water and why water is so important to life, okay? And so water actually has got some specific properties that make it important to life, and why it's really essential for us as living beings. And then we'll talk a little bit about the pH scale and buffers. So water is the most abundant molecule in living things. It makes up about 70% of us, and it's polar. What does that mean? It doesn't mean like polar pop or cold. It means that water, like the oxygen is partially negative and the hydrogens are partially positive. So they have like kind of unequal charges to this molecule. And this allows for water molecules to bond to each other, okay? And because they bond with hydrogen bonds, which are weak bonds between water molecules. So those are hydrogen bonds. And so that slightly positive hydrogen is attracted to that slightly positive negative. And these are relatively weak. Thank goodness, because that's why you're not dead after you jump into the swimming pool. That those bonds are weak, so you break those bonds, being able to go below the surface of the water. They're also highly attracted to each other. That's why there's not like a big hole there. Those bonds come right back. And so the surface of the water closes back up. So that's kind of what a hydrogen bond is. Now, properties of water, the things that are important for us to know in this class is why water is important to life. So first off, water has a high heat capacity and high heat of vaporization. That's why we sweat. Okay? And then it's a solvent. So it's our universal solvent. So outside of your hydrophobic molecules like lipids, fats, oils, most things will dissolve in water. And so solution itself is the water with whatever the dissolved stuff is in it, okay? Saltwater solution. The salt dissociates, the water dissolves and breaks those bonds, and then it allows for the salt, you see that at the bottom of your cup, okay, if it evaporates. But it will not dissolve fats. So fats and oils, hydrophobic, doesn't dissolve it, okay? That's why, like, if you get oil on your shirt, you have to use like Dawn dishwashing liquid because soaps are fats. So water molecules are also cohesive and adhesive. And what that means is that water molecules cling to each other with hydrogen bonds, and they flow freely without separating. It's how like water travels from the root to the top of the tree. Adhesion is when it clings to surfaces like blood vessels or like your Bounty picker, your Bounty paper towel. Excuse me. So when you put that tip of paper towel in that water droplet, it climbs up that paper towel. So that is adhesion. And frozen water is less dense than liquid water. It expands as it freezes while ice floats. And then if we talk a little bit about acids and bases, okay, acids release hydrogen ions where bases release hydroxide ions. And the importance of this is essentially your pH scale. Your blood is a 7, which is neutral. And our body wants to maintain that homeostasis. And so we want to stay at that neutral level, all right? Sometimes things happen where our blood acidity goes up or down, and we've got buffers. And those buffers release whatever it is we need. If it's hydroxide ions or hydrogen ions, it releases or takes up those things so that our blood pH goes right back to that neutral, normal place. And so we don't die, because like our blood, we can't be at a very high acidic or a basic level in our blood for very long, or we'll go into stroke, into coma, And like we said in chapter 1, our body wants to be at that homeostatic, balanced place. Now, that's going to be it for this piece of chapter 2. I have one more section of chapter 2 to talk to you guys about, and I will post that tomorrow. We're going to talk about the molecules of life, those macromolecules. And then chapter 2 will be finished. And then hopefully chapter 3 won't be 3 lectures, but I don't want to inundate you with a ton of lecture. So have a good night. And if you have any questions, feel free to email me.